Session 6, Regression Analysis and Stata Output. In this session, I will be introducing the comment for regression analysis and producing Stata output. I will first briefly share the idea of this comment, and I will show how to use this comment in using the final project as an example. So we've already covered the idea of regression analysis in class. So the comment for performing the regression is pretty easy. You just need to use the comment regress, which has an abbreviation of reg, and then followed by the dependent variable and then the independent variable. So that is for a simple linear regression, you have reg yx, or for a multiple linear regression, you have reg y x1, 2, 3 for how many variables you'd like. There are still several options that can be used with this reg comment. For example, the if option can be used, and there are others which I will not cover in this session. So for producing state output, the first thing to notice that since different researchers will use different statistical programs, so we never really just simply paste the raw output from those statistical programs into the manuscript, into the articles. For Stata, there are many useful comments that can be used for producing nice output. For example, Est Post, Est Tab, outreg, and so on. There are really many out there. So for today's session, I will just be introducing some of the comments that I personally use and I found it useful. But I'm sure in your future learning, you may encounter other comments that you may find useful. Okay, so one of the idea of this comment is by using this comment, they will automatically produce a Word document with the nicely formatted table for you in a folder. So it's actually very important to set the change of directory whenever you are producing a table or producing a file that has the table, because later on you know where Stata has saved those tables or files. And of course, once the Stata produced those tables, it's important to examine the table and maybe further edit the variables in your table. And also, it's always good to have a captain or title of the table. So always provide a captain, and if you have multiple models, sometimes it's important to label those models. For example, model 1, 2, 3 or model ABC, so that in your manuscript you can refer to, for example, model 1 in table 3, and then you can write the interpretation there. So in social science, this is a pretty standard and simple regression output. Usually, you present your regression models as a column, where if you have the dependent variable, you may want to indicate what is the dependent variable. Sometimes the name of the dependent variable may not be written, but was represented in the captain of the table. Usually you have the variable name as the independent variables in each row, and immediately you have the coefficients, the estimated OS estimators or the coefficient written. And below that, usually we will produce the standard error of the coefficient. So for example, you have, say, this is beta 0 hat, and then you have the standard error of beta 0 hat. And with these two information, if you use beta 0 hat divided by the standard error of beta hat, you can easily find the test statistic, the T statistic, which is automatically reported in the Stata raw output. But since we don't really use that test statistic so much, you just produce the beta hat and the standard error of beta hat. But in addition, in order to show the single significance test of a single coefficient, usually we would like to indicate the p values according to the 3 conventional value. So if a coefficient is statistically significant at 10%, we're going to have one little star, at significant at 5%, 2 stars, significant at 1%, 3 stars. This is based on the p-value. So you can use a comment to let the Stata to give Stata a criteria. Whenever the p-value is smaller than that, you're going to label that coefficient with 1, 2, or 3 stars. At the end of the observation, usually we would like to provide some additional, for example, goodness of fit measures and the number of observations. So in this case, we have observation and R squared reported here. So although very simple, but this is already a very informative table to show how many regressions are performed and what are the important regression results. There can be more complicated regression result, but it really shared the same idea. So you have a number of the table and some title for the table. You could have as much as 7 models fitted in this table. And if you have different dependent variables, so you can also mark what is your dependent variable and what type of model is used. So for example, there are some special sample selection models or some separated models. And in this research, they have so many independent variables. Okay, but again, every coefficient is labeled with according to the p-value, and the standard error is included within the parentheses. Usually at the end of the table, we'll put an additional note saying that standard errors in parentheses and the levels indicating the p-values. It's also possible that sometimes you see a paper that report the t statistic in the parentheses. So usually we provide a note here. Okay, and also in this research, they produced some special R square, some other log likelihood tests and so on, because this is not an OS regression, some other regression, and also the number of observations. Okay, so this is just a one-page summary for you for the 3 tables needed for producing some nice Stata output. I will come back to this page whenever we need for producing these tables. So next, I will talk about our final project using the example scenario, which use a topic on the earnings in Thailand, use data earnings. So a high school principal in Thailand wants to show his student how important education is for their future success. He studies a random sample of recent students from his high school, records their highest grade of completion and their monthly summary income. He also records their IQ and a binary measure for gender. He will prepare a report for his findings. So next, you can launch Stata. Okay. So part 1, data and descriptive statistics. So the first thing is you need to load your assigned data set, which is in an Excel file, into Stata and explore your data. How many observations do you have? How many variables do you have? Identify the role of each variable. So in order to import an Excel file, you need to go to File, Import, choose the Excel spreadsheet, locate where the file is, and you will have different worksheets. So make sure you select the one that is assigned to you. So my example is this earnings data set. I also want to make sure that I want to import the first row as variable names. So now click OK. I have 4 variables successfully loaded. It's always good to take a look at your editor browser. Okay. But for a simple comment to take a look at your data is to use describe. So this describe, I know I have 935 observations for variables, right? And of course, by reading your scenario, you can quickly identify that my dependent variable is wage, my independent variable is education, and I have 2 additional omitted or controlled variable. One is IQ and one is male. Okay. Create a histogram for your dependent variable, observe its distribution, and present figure 1. The command for histogram is already covered, and I will leave it up to you on whether you want to set, for example, a different number of intervals, different number of bins, or whether you want to include a normal curve. So whatever you feel like you present a figure that best illustrate your dependent variable, you can do that by yourself. The next thing is get descriptive statistic for all the variables, present the table in a table appropriate for research report or journal article. This will be your table 1. So the command for generating descriptive statistic has already been covered before. So I would like to talk about producing table 1 for this project. So what you need is to use a command that I usually use that's called ASDOC. I found this command to be very useful, which is written by an external user. So before you could use this command, if you've never used it before, you do need to download this ASDOC package. So to do so, you just need to type the command ssc install. So ssc install, that is basically the command for installing a Stata package. So the package I need is called ASDOC. So I'm gonna click enter, but you will see that my package has already been installed. But you might see a different message showing that your installation is completed. Okay, so once you have installed this package, you can utilize this command for producing your descriptive statistics table. The idea of the table is just to use ASDOC sum, comma, with any statistic that you would like to produce. Okay, so for example, actually before I want to give the comment, I want to first change my working directory. So later on, when it generates a Word document, I know where the document is saved. So I'm going to set my working directory to my Stata session. Stata session 6 under the final project. So click OK. So now I know this is my working directory. Whenever there's a file generated, it's going to be saved there. So next, I'm going to run my comments, ASDOC sum, comma, stat, mean, standard deviation, minimum, and maximum. So click enter. Once you click enter, you will first still see this summary comment being executed. In addition, you will see a file where you can open directly from here, but whenever later you close your Stata program, you still know that you can find this file in your folder, in your working folder. Okay, so I'm going to click from here. If you open this file, you see that relatively nice Stata output on summary statistic is basically generated for you. I do not recommend you to do any editings on this table, which I will talk a little bit more later. Okay, so the next thing is, of course, you can also include some additional statistic, for example, the median, the 75 percentile, and so on, included in your descriptive statistic. You can just continue to include them in the parentheses of this stats comment. In addition, sometimes you don't want to create a descriptive statistics table for all of your variables, or you would like this table to have the variables in a different order. If that is the case, you want to identify and list those variables and after this sum. So for example, in my case, I don't like that my IQ goes to the second because my main independent variable is education. So in order to change the order, I'm going to list the variables as wage, education, IQ, and male. And I'm also going to let Stata to produce the number of observations for each variable. So now I'm going to click enter. once I click enter, it will says that this file has already existed, so it appended this new table under the previous file. Okay, so now if I open this file one more time, you actually see two tables, and this second table is actually generated for you. So this is why I don't recommend you to do any editings on this my file file. One of the little kind of limitation of this comment is that it's always going to create a file that's called my file and append everything after this file. So it's kind of like recommended that you don't edit from here. So you just copy paste this table to your technical report, and then you can probably edit this table in your own Word document. So for example, I'm going to create a new Word document, copy this table, and then I'd like to further edit this table. So I want to label it as my table 1 summary statistic of the variables used. And I like to change my variable name, which is education, IQ male. And so sometimes I would like to call it observation, standard deviation, mean, and max. Okay, so that looks nicer, but it's really up to you to whether you want to continue to add the table, or once you select this table, you have some other table design by a Word document. But I don't really need you to do any more fancy tables in the final project. This looks already good. Okay. Okay. So part 2 requires you to do some simple correlation analysis to examine the bivariate relationship. So you know how to use comment to find the correlation coefficient, how to create a scatter plot with the fitted line, and how to create correlation matrix to explore the bivariate relationship. But in this third part, I required you to create a correlation matrix and also present it in table 2. So to do so, we also have a nice comment that shows a good correlation report. So the comment is ASDOC, still that one, but followed by COR. Because this comment is written by another user, so the abbreviation is not CORR, it's only COR. Again, if you only want to include several but not all variables and with certain orders, you may want to do just list all the variables that you need. Okay, so actually before you create additional tables, you may want to close this table so that this table is not left open, and don't save anything. So now I'm going to run ASDOC COR, and I want to do wage, education, IQ, and male. Click enter. So this append comment was used one more time. So if you click on my file, you see the third table being produced for you. And then of course you can copy paste this table into your technical report and continue to edit this table. So name it as table 2 and the variable names as well. But it's good to see that you have some nice correlation matrix table generated for you, right? So wage and education has a correlation of positive 0.3, and you can continue to examine the correlation between wage and other variables. It's actually also important to notice that the correlation between education and IQ is pretty strong. It's about 0.5. So we have strong reasons to expect that this IQ is going to be an omitted variable. So if it's omitted, it might create an omitted variable bias on the estimator for education, because it may not be the full effect of education on wage, it could be the effect of IQ. So it could be the case that whenever you run a simple linear regression, you are overestimating the effect of education. Okay, so this is something that is important to notice. Okay, so the last thing that I want to comment on this ASC file is if you feel like you don't want to have this so many tables here, or you want to regenerate new tables that override all of your previous tables, what you need to do is you only need to add one more option that is called replace. So suppose I only want to include this one correlation matrix table, and I don't want to keep adding into the previous one. You just need to add an option that's called comma replace. Click enter, and all of your previous tables are gone, and you only have this one new tables here. Okay, but usually I just don't do that. I just let the Stata to create as much as tables needed under this my file document, and I'll just move this table to my manuscript and edit my manuscript from there. So I'll not save that. Okay. So moving on, the third part of the final project is to perform linear regressions. We start from simple linear regressions. Based on the research questions, state the population regression model, which is wage equals to beta 0 plus beta 1 education plus U, the little arrow term. State the non and alternative hypothesis both in simple and words. So my non-hypothesis would be beta 1 equals to 0. Remember, the non-hypothesis or the hypothesis is always about the population parameter, always about this unknown value. So you should never write as beta 1 hat equals to 0, because you will estimate beta 1 hat. So your hypothesis is about beta 1 equals to 0 against the alternative hypothesis where beta 1 is not equals to 0. So the interpretation is that your non-hypothesis is that education has no statistically significant impact on wage against the alternative hypothesis where education has a statistically significant impact on wage. Remember, the alternative hypothesis is our research hypothesis. We are hoping to reject the non in order to support our research hypothesis. Okay, therefore, in order to test our hypothesis, we want to state some linear sample regression model, which is basically the wage hat equals to beta 0 hat plus beta 1 hat education, and we are hoping to run a regression to find beta 0 hat and beta 1 hat. So we're going to run the simple linear regression of y on x1. I'm going to write reg y on x1. Click enter. You will see this regression output, which are covered in our lecture. You should be able to find the coefficient, find the R-square, find the test statistic, find the p-value, anything that you need to help you answer all these questions. Right? So since p-value is very small, you are able to reject the non-hypothesis at 1%, 5%, and 10%. So basically, you found you found sufficient evidence to support that education is statistically significant on wage. Report, interpret, and then if it's statistically significantly from 0, of course, you can then interpret the sign and interpret the magnitude of beta 1 hat. Also report and interpret your R-square, but more importantly, as we discussed in class, simple linear regression is never enough. There's always omitted variable bias. So discuss briefly, do you think beta 1 hat is an unbiased estimator of beta 1? Use the other independent variable x2 as an example for discussion. So in my example, I would discuss that this beta 1 hat, which is the effect of education on wage, may not be accurate, may not be unbiased. There might be an omitted variable, for example, IQ, that is also influencing wage and correlated with my education. So part of the effect in education might be the effect of IQ scores, right? So basically you discuss if we omit that IQ score into our regression, then the coefficient for education might be overestimating the effect or underestimating the effect, right? So just intuitively discuss that, and then in part 4, you will be able to include that omitted variable to check whether your models has been improved. So part 4 will first allow you to run another regression that includes the independent variable x2, which is IQ. You want to observe and report the statistical significance of that variable. So first take a look at whether that variable has a statistically significant effect on y, whether it's a determinant of y, right? Remember the two conditions for an omitted variable bias. So now I'm going to run my second model, which is reg wage education and IQ. So click enter, look at some statistics, and my IQ is also, so the null hypothesis that beta 2 equals to 0, and I'm able to reject it at 1%, 5%, and 10%, right? So of course you can interpret IQ, but more importantly, it's important to discuss that observe the change in the coefficient of x1, how the coefficient has changed once you included the omitted variable. What about the change in R? So make some more descriptions on the change between the two variables in your technical report, right? So as you see, education has decreased from 60 to 42. So previously, when IQ was omitted, the effect of education was overestimated. Okay, and in addition, by including another important factor of weight, another factor of IQ, the R square has improved. The R square previously was 10%, now it's about 13%. Okay. So the next one, you are going to run the third regression with all the variables, which is to include the last dummy variable of the selected group. So observe and report the statistical significance and interpret the variable. What does it say about the control group? So first run the third regression, which is to add the last variable, gender. So male is my 1 here. So the value of 1 if it's male, the value of 0 if it's female. So click enter. First notice that this is another statistically significant variable. The coefficient, or this beta 3 hat, is 200. So I'd like to interpret that being a male is associated or has a weight that is 200 unit higher than being a female, than being a membership as a female, right? And don't forget to say holding education and IQ constant, or holding other factors constant, holding other factors fixed. Okay. Also take a look at the F-test for this model 3. So F-test is here. The p-values is pretty always 0, 0. So it's very easy to reject the overall significance, especially all 3 variables itself are statistically significant. So the overall significance is also good. So overall, the coefficients are statistically significant. What about the change in R square? Compare the adjusted R square across 3 models. Compare the multiple linear regression and simple linear regression, conclude the relationship between y and x1. It might be good to talk about the last 2 points whenever you have all three models produced in one table. So I'm going to first introduce how to use a comment to produce regression result. So the comment we're going to use is called an Est tab. So, but the thing is, this Est tab is going to generate your regression result, but before it can generate a regression result, you're going to use an Est store to store that result. And this Est store has to be used after every regression comment. So you perform a regression and use Est to store it as, you can have different names. You can store it as A1, R1, or Reg1. And then you perform another regression, and then you want to store it as A2, R2, or Reg2. And then you can produce this tab. You want to generate however models estimation result you'd like. But let me first do the 3 regressions one more time, but this time between the regressions, I want to store each regression. So I'm going to regress my y on x1, I just did, and then Est store, you can name it however you want, just reg1, and then I'm going to run my second model, Est store reg2, run my third regression, store Est store reg3. So now I have successfully run my 3 models and stored all the necessary results into Stata. But I need to let the Stata to produce it. I actually recommend you just copy paste this whole line of comments. Copy and paste. Okay, so this comment is really, first of all, you need to adjust here a little bit because you want to produce all 3 estimation results. So you're going to tab reg1, reg2, and reg3. Second of all, unlike the AS.doc, which will always create a file that's called a my file for you, here it's gonna create a file where you can name it however you want. So you can name a file that's called my regression. You can name a file that's called regression May 1st. It's really up to you. So you can change the name here, but usually it's followed by some option that's called using some file and comma. After the comma, you can basically include some additional stuff, and these are the ones that I'd like to include because those are useful stuff to report. So I'd like the Stata to include R-square and adjusted R-square. So these 2 are for the R-square and adjusted R-square. So this little thing is really about that I'd like to keep my standard error in the parentheses with 3 decimal points. Remember, the standard estimation result always have the standard error below the coefficient in the parentheses. The last thing, which is to say that also I'd like to label 1 star, 2 stars, 3 stars according to the p-value on the coefficient. Okay, so you don't need to remember this, just copy paste this, and then you can always use this comment to create some standard estimation output. So now I'm going to click enter. I may not copy it very well, so I need I think I need a space here. Okay, so click enter, it worked. Okay, so now output written to reg.rtf. This is a formatted Word document. You can open it from here, but you also know that since you change your working directory, you can also directly open here without launching Stata later on whenever you want to work with the table. Okay, so I'm just going to open it here. So basically, you have some regression output for you, where the coefficient is reported with the statistic significant level indicated. So the standard errors is included in the parentheses. So you have these notes here. And so you have 3 models, one y on x1, second one y on x1, x2, the third one y on all the variables, right? You can also, whenever you want to compare three variables, it's good to take a look at the R-square and saying that not only the R-square has improved, even if you have taken into consideration of having more variables, your R-square still improved, right? You see the adjusted R-square is a little bit lower than the R-square because it always puts a penalty on the number of independent variables included, right? The three variables where the model can explain 15.5% of the variation in weight. Again, having low R-square does not mean you have a bad model. It means that there are a lot more other factors that can also explain weight. Okay? But you can also tell that your coefficient for education has decreased from 60 to 42, but also increased a little bit to 44. This might be the case where some other factors that is kind of reflected or correlated by male has kicked in. Okay, so once you controlled for gender, the coefficient becomes 44. So we can more or less conclude across the three models that we do have some robust result that education has a statistically significant result. At least it doesn't matter how many variables, more variables we controlled for, education is still very, very statistically significant and at 1%, right? So it's a very robust result that education has a non-zero impact, has a statistically significant impact, right? And we believe being the best model as the third model, when education increased by 1 year, the average wage will increase by 44 years, controlling all other factors. Okay, so that's all. So please carefully read the instruction for the final project and the suggested write-ups. And if you have more questions, you can let me know. But this session is about running regressions and producing all three nice tables for your technical report. Thank you.